All right, this is one of my favorite coding problems of probably of all time. So it's a very classic linked list problem. So basically, it's trying to you're given a head of the head of a linked list. You're trying to determine if this linked list has a cycle in it. So it means that you have 3, 2, 0, 4 or -4, and then -4 is pointing back to 2. So minus for this node, the next value, right? So this dot next is equal to 2, and then it point to 0. So it keeps going into this cycle. So we have to detect if any given linked list has a cycle or not. So this is one of the most popular problems in interviews. So basically, if you look at this cycle here, right, we're gonna have to define 2 pointers, and one pointer is going to be updated to its next node. So if I have a 3, that's called a fast pointer. So it's moving 2 nodes at a time. And we're gonna have a slow pointer that's moving 1 node at a time. So you have a fast pointer, you have a slow pointer. So just think about it. If the fast pointer is moving 2 nodes at a time and the slow pointer is moving 1 node at a time, and then relatively speaking, right? So the fast pointer is moving 1 step faster than the slower pointer, right? That's obvious. So if you put that into a cycle, if it has a cycle, then eventually these 2 pointers will always have to enter into this cycle, right? So you just keep looping here. Say fast pointer reached the cycle first at 2, then the next value will be 4, and then the next value will be 0, and then the 2 to 4 to 0, and then keeps going, right? So, and the slow pointer will be entering the cycle at 2, then 0, then -4, then 2. Just think about it. So if both pointers are in the cycle, and fast pointer is moving one node faster than the slow pointer, eventually they're gonna land on the same node, right? Because I'm chasing you. The fast pointer is chasing the slow pointer 1 node at a time. Eventually they have to arrive at the same node. So we can leverage that and code our problem. So basically, first of all, we have to define 2 pointers. So you have a fast is equal to head, and then you have a slow is also equal to head, right? So we're gonna say if fast dot next is not equal to null, and because we're moving fast 2 nodes at a time, so we have to say fast dot next is not equal to null, right? So and then we're gonna update these these pointers. So slow is equal to slow dot next, and fast is equal to fast dot next, right? So and one trick to avoid null pointer exception here is that you look at these whatever is in the loop, and you try to figure out the rightmost element you want to go at each step. And in this time we're going to the next pointer fast, so we're going 2 pointers away from fast. So you have to add a null check here to make sure the value that you're going to is not equal to null. Otherwise you can break the while loop, right? So all right, so we have this basic setup here, and then we can just say if slow is equal to fast, that means they eventually meet and land at the same point. So then I'm gonna say return true. That means there is a cycle. Otherwise, I'm gonna return false. Pretty straightforward, but pretty sweet. So let's submit the algorithm. Cannot refill because it's not okay. So let's see, line 17 cannot. Okay, we may have to add a basic here. So if head is equal to null, then return false. right? So that guarantees that the next is actually going to be the fastest is not going to be null, so we'll not run into a null pointer exception. All right, so there we go. That would be a classic solution for these kind of problems, and you can remember this fast and slower pointer approach. It's a very popular approach to a lot of linked list questions.